Hi, welcome to the third calculus tutorial. Today's tutorial is titled Sketching the Third Degree Graph. That is, graphs with the form y is equals to ax cubed. In terms of what you need to know to progress with this tutorial, you need to have mastered the sections functions and algebra, as well as the previous two calculus tutorials. You will notice as we progress through this tutorial that there are a number of different techniques that we integrate into each example, and this makes it a fairly complex section. I want you to feel free to press pause and rewind as often as you need to. We will begin by looking at all of the steps involved in sketching a third degree graph. We will use a function of standard form. F of x is equals to ax cubed plus bx squared plus cx plus d. Step 1. We look at the a value. If the a value is positive, the graph will have an N shape. If the a value is negative, the graph will have this shape over here. Step 2. We find the y-intercept. The way we do that, we make x equals to 0, or rather we are looking for f of 0. Step 3. We are now going to look for our x-intercept. Hence we are making y 0, or rather we are looking for f of x equals to 0. Now step 3 is going to be a fairly complex one, and you will see that when we go through the example. Step 4. We look at the turning points. In step 4 we are going to be looking for the x values of the turning points. In other words, we are looking for when the derivative or the gradient is equals to 0. Step 5. We are going to be looking for our y coordinates of the turning points. That's after we have found our x values of the turning points. Step 6. We take all of the information we have collected above and we sketch our graph. Now let us take a look at an example of sketching a third degree graph. The graph we are going to be sketching is f of x is equal to x cubed minus 6x squared plus 9x minus 4. The first thing I'm going to do is I'm going to look at my a value. In this case my a value is positive 1. That means my graph is going to take that shape. The second thing I'm going to do is I'm going to look for my y-intercept. Y-intercept happens when x is equal to 0. That means we are looking for f of 0, which will equal negative 4. So my y-intercept happens at 0 and negative 4. The third thing we are going to be looking at is our x-intercepts. Now, because there is an x cubed, it means that there are probably going to be 3 different x-intercepts. I'm going to start this by finding my values for which f of x is equal to 0, i.e. the values for which x cubed minus 6x squared plus 9x minus 4 is equal to 0. This is simple factorization that we did in the previous tutorial. Using trial and error method, I can find that f of 1 is equal to 0. That means that x minus 1 is a factor. If I multiply that in, x minus 1 into x cubed minus 6x squared plus 9x minus 4, That's going to give me an answer of x squared minus 5x plus 4. Please note you've got to do the full long division here. I just skipped out the step because I pre-prepared this answer. That means that f of x is going to equal x minus 1 multiplied by x squared minus 5x plus 4. This can factor out into x minus 1 multiplied by x minus 4 times x minus 1, which is equal to x minus 1 squared times x minus 4. But remember, I said that it needs to equal 0. That means that either x is equal to 1 or x is equal to 4. Take note of this one here. I did say initially that there might be 3 x values. In this case there are only 2 x values because 2 of the x values are here. That means that this is probably going to be a turning point. Not probably, that's definitely going to be a turning point. That was our x-intercepts. We now are going to look at our turning points. That's step 4. The turning points happen when our derivative is equal to 0. In this case, our derivative is 3x squared minus 12x plus 9 is equal to 0. I can first take out a common 3 as a factor. That will leave us with x squared minus 4x plus 3 is equal to 0. That means that x minus 3 multiplied by x minus 1 is equal to 0. That means that x is equal to 1 or x is equal to 3. I told you that point was our turning point as well as an x-intercept. Now this is only my x values of my turning point. Step 5, I still need to find my y values of the turning points. F of 1 will give me 1 cubed minus 6 multiplied by 1 squared plus 9 multiplied by 1 minus 4, which is equal to 1 minus 6 is minus 5 plus 9 is 4 minus 4 is 0, and that's right. That means our one turning point is 1 and 0. Our other turning point is going to be f of 3, which is going to work out to be negative 4. That means that our second turning point is 3, negative 4. Now let us move on to the sketch. When you sketch your graph, please don't worry about doing it too neat while it's just for study purposes. In your exam paper you can do a neat graph, but for now let's just go with something a bit untidy and rough. The first thing we're going to put on here, or rather the first thing we're going to look at, is this here. Our a value was positive 1. That means that our shape of the graph is like that. Keep that in mind. The next thing we look at, our y-intercept being 0, or rather when x is equal to 0, our y value is negative 4. That will come somewhere over here. Let's just call that negative 4. That means that that point over there is our y-intercept. The next bit of information we have is our x-intercepts. Our x-intercepts, we found it to be x is equal to 1 or x is equal to 4. That means that our one intercept is over here at x is equal to 1. Our other intercept is somewhere over here. Let's put it a bit closer, at 4. We then look at our turning points. Our turning points, remember, worked out to be x is equal to 1 and x is equal to 3, and the corresponding y values were 0 and negative 4, put these points in. The first point, 1 and 0, is going to be exactly there, and the second point, 3 and negative 4, is going to be, actually it's going to be a bit further up, it's going to be somewhere over there, right? Remember, I did say that this is the x-intercept as well as the turning point, and it worked out that way. Our graph has that type of shape, so it's going to turn at the turning point, x is equal to 1, y is equal to 0, turn again at the turning point, x is equal to 3, y is equal to negative 4, and it's going to go back up and it's going to intercept over there. And this is the graph f of x. Notice how many different concepts came into play when I was doing that example. That is why at the start I emphasized that you know your algebra and function sections well before moving on with this tutorial. I want you to now have a go at the following examples. Welcome back. I hope that you enjoyed drawing those graphs. They are a bit tedious to do, that's why I only gave you 2 to draw. The first one read g of x is equal to x cubed minus 7x squared minus x plus 7. I also told you that x minus 7 is a factor. The first thing that we do with graph sketching is we look at our a value. In this case, a is equal to positive 1, which means that the graph has the N shape. Second step, we look at our y-intercept, which happens when x is equal to 0. Hence we are looking for g of 0, which is going to equal 7. That means our y-intercept is 0, 7. Notice that I always put my intercepts and all of my points as a set of coordinates. Please do that, it does make it a lot easier when you are sketching your graph. Third step, x-intercept happens when y is equal to 0. In this case it will be when x cubed minus 7x squared minus x plus 7 is equal to 0. Now I did tell you that one of the factors are x minus 7. All you need to do in this case here is do synthetic or long division to get your results. That will be x cubed minus 7x squared minus x plus 7, and it's going to be divided by x minus 7. Long division, again, x, let's just write that properly, x into x cubed goes x squared times x is x cubed, x squared times negative 7 is negative 7x squared. Change the signs, that works out to 0, that works out to 0, doesn't matter, bring the negative x down. 0 divided by x is 0, 0, 0, don't need to change any signs. Negative x, bring the positive 7 down, negative x divided by x is equal to negative 1. Negative 1 times x is negative x. Negative 1 times negative 7 is positive 7. Change the signs, that should work out to 0. Yes, it does. That means that g of x is equal to x minus 7 multiplied by x squared minus 1, which is the same as x plus 1, x minus 1. That means that our three values for when g of x is equal to 0 will be given by x is equal to 7, x is equal to negative 1, or x is equal to 1. The coordinates would be 7, 0, negative 1, 0, and 1, 0. And that's our x-intercepts. We are now going to look for our turning point, which is the fourth step, or rather the x value of our turning point. That's going to be when the derivative of g of x is equal to 0. That's where the graph turns. Derivative of g of x is going to be given as 3x squared minus 14x minus 1 is equal to 0. Now unfortunately this one again cannot be factorized. We're going to have to use the quadratic formula of x is equal to minus b plus minus square root of b squared minus 4ac, all of that over 2a. Thankfully you guys have all got very advanced calculators, so it's an easy one to do. That means that your two x values are going to be given by x is equal to 4.74 or x is equal to negative 0.07. Remember again, this is only our x values. Step 5, we need to get our corresponding y values of the turning point, which is going to be given by g of 4.74, not g dash, g of 4.74, or rather and g of negative 0.07. G of 4.47 is going to give me an answer of negative 48.52. G of negative 0.07 is going to give me a y value of 7.04. That means that the coordinates of our two turning points are given as 4.74 and negative 48.52, that's 0.1. The other point is negative 0.07 and 7.04. Step 6, we sketch it. Let us look at the sketching of this graph. Our x-axis, that's our y-axis, which is going to go very high and very low. Notice again that I am not doing a very accurate graph. That doesn't matter. Alright, step 1, we looked at our a value. Keep in mind that it's going to be shaped as an N. Step 2, the y-intercept. Let's put that in. The y-intercept happens at 7, positive 7. I'm going to put that in over here. Step 3, we are looking for our x-intercepts, or rather we found our x-intercepts to be these 3 points. Negative 1, 0 is going to come over here somewhere. 1 and 0 is going to be over here, and the other one, 7 and 0, is going to be over there. Let's just extend the 7 a little bit further upward. Alright, then we just need to look at our two turning points. Our turning points are given by these points over here. The first turning point is positive, x is equal to positive 4.74, which is somewhere there. Negative 48 is way down here, somewhere further down in fact. And the other turning point is at negative 0.07, which is just past the 0 mark, and 7.04, which is just a bit over that mark. So I'm going to rather move my 7 to that side. That means that my other turning point is more or less there. Remember, it is the N shape, which means that our graph is going to turn at the turning point, cross the y-intercept through the x-intercept, turn at the next turning point through that intercept. And this is the graph g of x. The second one I gave you to do read h of x is equal to negative 2x cubed minus 6x squared plus 56x plus 120, and I also told you that x plus 2 is a factor. Again, first thing I'm going to do, I look at my a value. In this case it's equal to -2, which means that my graph has the opposite of the N shape. I don't have a letter for that. Step 1. Step 2, we look at our y-intercept, which happens when x is equal to 0. That is, we are looking for h of 0, which is going to equal positive 120. That is our y-intercept. Step 3, we look for our x-intercepts. That happens when y is equal to 0. In this case it means that minus 2x cubed minus 6x squared plus 56x plus 120 is equal to 0. Start by dividing through by a common -2. So this will make it x cubed plus 3x squared plus 28x, minus 28x, because we're dividing through by a negative, minus 60 is equal to 0. I did tell you that x plus 2 is a factor, so we will say x plus 2 into x cubed plus 3x squared minus 28x minus 60. X into x cubed goes x squared times, that will be x cubed. X squared times plus 2 will be plus 2x squared. Change the signs, that comes to 0. 3x squared minus 2x squared is just x squared minus 28x. X squared divided by x is equal to positive x. X times x is x squared. X times positive 2 is positive 2x. Change the signs, that leaves us with minus 30x minus 60. Minus 30 divided by x, minus 30x divided by x rather, is equal to minus 30. Minus 30 times x is minus 30x. Minus 30 times positive 2 is minus 60. Change the signs, that should equal 0. Yes, it does. That means that this is the same as saying x plus 2 multiplied by x squared plus x minus 30, which is the same as x plus 6 multiplied by x minus 5 is equal to 0. Alright, now that we've got that down, that means that our x-intercepts, our three x-intercepts, are given by -2, 0, -6, 0, and positive 5, 0. We now look at our turning points. First, let's look at the x values of the turning points. That's when our derivative h dash x is equal to 0. Basically, that's when minus 6x squared minus 12x plus 56 is equal to 0. Divide through by a -3. Divide through by a -2, which will give us 3x squared plus 6x minus 28 is equal to 0. This year we are going to have to use the formula to get our two x values of x is equal to 2.21 or x is equal to -4.21. I now use that information to calculate my y values of the turning point. It will be given by h of 2.21, which will equal 192 72.87 or h of negative 4.21, which will equal negative 72.87. This means that my turning points are given by an x value of 2.21 and a corresponding y value of 192.87, and the other turning point is given by an x value of negative 4.21 and a y value of negative 72.87. Right? We are now going to sketch the graph. My y-axis is going to be a very big one on this graph, x-axis not so much. Alright, first thing I'm going to look at is the shape of my graph. Remember that a was negative, which means that my shape looks something like that. Keep that in mind. The next thing we are going to look at is our y-intercept. In this case, you will remember that our y-intercept worked out to be 120. X is equal to 0, y is equal to 120. So that's going to be somewhere way up here. That's fine. Our x-intercepts when y is equal to 0 will work out to be -2, -6, and +5. I am not drawing my graph accurately. Please keep that in mind as well. My turning points are given by -4.21 as my x value, my y value -72.87. That's going to be somewhere down here. And my other turning point is 2.21 and a +192, which is going to be somewhere up there. So my graph is going to look something like that. Obviously this is an inaccurate graph, and this is h of x. Please always label it. And that brings us to the end of the third tutorial under calculus. The next tutorial is a very fun and practical tutorial dealing with the application of differential calculus. I look forward to seeing you guys there, but before you do, go through the examples I've left for you in the workbook.